All right, everybody, we're on lesson number 7, page 551. We are starting to do big graphs, just continuation of lesson number 6, but we're introducing transformations. So the very first unit that we learned. We have A values and B values. So if you remember, an A value is a vertical stretch. A B value is a horizontal stretch. And then we called these H and K, I believe. We're going to call them C and D. So C, because it's inside of the X, is going to move it left or right. It's a horizontal translation, but I'm just going to say left, right. And the D value is up, down. So it moves it up or down 3 units or 4 units. Okay, so, and hopefully you remember what the sine graph, these first few are going to be all sine graphs. So the sine function starts at 0, goes up, has a period of 360 degrees, or 2 pi, and has a max value of 1 and a minimum value of 1. That is sine of x. And a cosine starts at 1, goes down, goes up, again, a period of 360, or 2 pi, and has a max value of 1 and a minimum value of -1. All right, so if I have y is equal to 2 sine x, that means we have an a value equal to 2, and hopefully you remember that is a vertical expansion by 2, or you could just say vertical stretch by 2, i.e. multiply your y values excuse me, by 2. And you can see this on Desmos. Sorry. We have y is equal to sine x. Here's our graph. Oscillates between 1 and -1, has a period of 360 degrees. If I put a 2 in front of it, it expands it by 2. So the maxes and mins move to plus and minus 2, as you can see on the graph. All right. Next one is a b value. B is equal to 2, which means it's a horizontal stretch by, and remember, it's always 1 over that number, so it's 1 over 2. Okay? This horizontal stretch here is 1 over b factor. So b is 2, the horizontal stretch by half, which means you actually compress it. Okay? So if we take our sine graph and put a 2 inside there, and you can see now the period goes to 180 degrees. Okay? The graph was pushed in sideways, so the period's been cut in half. It's been squished together. Alright? This -3 here. So our a value is -3. The negative is a flip over the x-axis, and the 3 is a vertical stretch by 3. So our maxes and our mins should move to 3, and we should get a flip over the x-axis. And just to show you that is the case, back here, and I put a -3, so then watch this point right there, 90 and 1. When I put a -3 in, well, I put a negative in, it flips down, and if I put a 3 in, you're going to see everything expand to 3. So it's been flipped over the x-axis. Sorry, did I say y-axis? Oh, x-axis. Okay, what about this? That's our b is -3. The negative causes it to flip over the y-axis, and 3 is a horizontal stretch by a third. So let's go back, erase all this. So we have regular sine. You'll see as soon as I put the negative, you're going to see this point here, we have to negative 90. You know, across the y-axis. Boom, there it is right there. Negative 90. And then if I put the 3 in, it compresses it horizontally. Okay. So, what do you think these values do? What does the A value do in terms of amplitude? All right. This A value, don't worry about any of that, changes the amplitude, which is max and the mins, by a factor of A. You just multiply by whatever A is, and that expands it, the maxes and the mins. The B value, now remember that compressed it sideways, horizontally. That changes the period of the graph. Changes the period by a factor of 1 over B. That's the key, it's 1 over B. So in a regular sine graph, we have an amplitude of 1. Okay, the max is max minus min, minus the min divided by 2 will give you 1. All right, it oscillates between 1 and negative 1. The period is 2 pi, or 360. If I put an A value of 2 in, that is going to change my amplitude. The amplitude now switches to 2. Nothing happens to the period, so it stays at 2 pi, or 360. If I put a 2 in for the B value, that does not change the amplitude, it still stays at 1. But the period gets shrunk. We multiply by a factor of 1 over B. So if my period is 2 pi, I multiply by 1 over B, so 1 over 2 becomes pi, or 180 degrees, which we saw in the graph. A value of negative 3. The amplitude, the negative doesn't change the amplitude, because if you look at it, if I put a negative 3 in there, it still oscillates between 3 and negative 3, okay? So the amplitude stays the same. Well, it doesn't stay the same, it turns into 3, but the negative has no effect. All the negative does is flip it, but doesn't change the amplitude. Period, because we didn't put a B value in, 2 pi, or 360. I put a B value of negative 3, amplitude does not change, so that stays at 1. The period is now 2 pi times 1 over B, which is 3. You ignore the negative because the negative just tells you that it's a flip. So I get 2 pi over 3, which hopefully you remember pi over 3 is 60 degrees times 2 of them, which is 120 degrees. And then the next one, we have an A and a B. So the A changes the amplitude, it's just 5. Essentially whatever your A value is your amplitude. And the B is just 2 pi over your B value, which is 4, which is pi over 2, reduces to pi over 2, which hopefully you remember is 90. Or 360 divided by 4, which is 90. Okay, fractions. A value is your amplitude. B value, remember, I'll do it in degrees this time, it's 360 times 1 over the B value, which is 1/2, which is actually 360 times 2, because you flip the denominator, the bottom fraction, so the period is 720 degrees. So in short, if you have A sine Bx, your amplitude is whatever A is. okay? And your period is 2 pi over b, or if you want to do it in degrees, it's 360 over b. And it works the same for the cosine function. And this is all summed up in these two tables right here. Okay? This is the one we just did, sine and cosine. The amplitude is actually the absolute value of A, as you saw here. When it was negative, our amplitude was still 3. So it's the absolute value of A, or max minus min. This formula is used when you have graphs. And you'll see that's the next step is we're going to be given a graph and we have to generate the equation. The period is 360 over the absolute value of B if you're in degrees, or 2 pi over the absolute value of B if you're in rads. Normally I would tell people that they need to memorize this, and you should if you're going on. But again, COVID, you have access to all these formulas, so what you need to do. All right. For a tan graph, amplitude, you can't calculate the amplitude, all right, from a graph. I can give you an A value, but you can't say what the amplitude is because if you remember, tan graphs look like this. They have asymptotes, so they just keep rising forever, so there is no max or min. You can't do that, okay? But I can give you an A value. It would be in the equation. The period, remember the period of a tan graph is 180 degrees, right? So it's 180 divided by b, and pi, or pi over b. That is the main difference. When you're doing tan, 180 over b, or pi over b. When you're doing sine, 360, or 2 pi divided by b, all right? This would be the point where I'll get you to do questions 1 to 4. All right, good luck with those, unless you're just going to continue with the video, which we're going to do right now. All right, 553. I'm not going to sketch this. We're not going to worry about sketching graphs. Consider the graph y is equal to 4 cos 2x. All right, state the amplitude and the period. Well, amplitude, here the absolute value of A is equal to my amplitude. The table we just saw right there. Okay, well, what's my value? It's 4. Therefore, there's my amplitude. To get the period, it's 2 pi divided by b. And they want it in rads because their domain is in rads. So the period is going to be 2 pi over b. What's my b value? Which means my period is just pi. That's it. I don't want you to sketch the graph, so don't worry about that. Now I'm going to tell you what the amplitude and the period are, and we have to figure out the equation. So remember, these are the general equations here. Okay, I'll write them here. Y is equal to a sine bx, and like it's the same for cosine. All right, so a sine function having an amplitude of 2/3. As soon as you see that, that's your a value. And a period of pi over 6. Remember, period is equal to 2 pi over b. We are trying to find b. They've given us the period. So that goes in for p. So pi over 6 is equal to 2 pi over b. You're going to multiply the b up, you're going to multiply the 6 up. So you're going to get b times pi is equal to 12 pi. If you divide off the pi, it cancels, and you get b is equal to 12. And now you know what b is, and you know what a is. So y is equal to 2/3 sine 12x. All right, a cosine function. So now we're just using a different trig function. Amplitude of 3, there's my a value. Period of 720. Remember, period is equal to, if you're doing it in degrees, 360 over your b value. I've told you the period is 720, so it's 720 is equal to 360 over b. Flip the b in the 720, so you get b is equal to 360 over 720, because this should be in degrees. 360 over 720 is 1/2. Their b value is 1/2. So this form is 3 cosine 1/2 x. And finally, tangent function having a period of pi over 2. Well, tangent function, remember, amplitude is not applicable. The only way you'll have an a value is if I tell you what the a value is. Okay? In this case, they do not tell us. They just say it has a period of pi over 2. Remember, for tan, period is pi over b. That's the big difference. Here it's 2 pi over b. Here it's pi over b. So we just put pi over 2 for period. So I get pi over 2 is equal to pi over b. So what does b have to be? Well, if you don't see it right away, since pi is equal to pi, b has to be equal to 2. But you could multiply those up and then divide off the pi, and you would get b is equal to 2. So our formula is, if they don't say anything about the a value, just assume it's 1. Okay, so you can say a is equal to 1. So it's just tan 2x. That's it. Questions 5 to 7, please, people. And then there's just 2 more left in this lesson. Very quick lesson. All right, so the next step is they give us a graph. We have to figure out the equation. All right. Okay, so here's our graph. It's either a sine or a cosine graph. They're gonna have it's a sine graph. You'll see later on you can do sine or cosine. That's the next lesson. But they're going to tell us right now what to do it in. So from a graph, that's the formula. A is equal to max minus min divided by 2. So max minus min over 2. What's the max value? 3. The min value, negative 3. Whoa. 3 minus negative 3 over 2. 3 minus negative 3 is 6 over 2, 3. So my a value is 3. What's the period? This is the hardest part for people. So you're going to look for, we'll just go to the origin. This graph is going up right here. So go along to the next part of the graph that is rising, which is right there. It's not this part because the graph goes like this. And through here, it's falling. So you have to go all the way to the next one that is rising, which is right there. So that, but I don't know what that number is. Well, they tell us that each line is pi over 2. How many lines? 1, 2 to get there. Okay. So I know that the period would be 2 times pi over 2, which is just pi. Okay. And now I know the period is pi. All right. Now they want us to generate the equation. So at this point, because I know A and P, it is just like these questions up here. So the general formula is A sine dx. I know what A is. A is 3. I do not know what B is, but I do know the period. So remember, formula, period is equal to 2 pi over B. So period is pi. Pi is equal to 2 pi over B. So B is equal to 2 pi over pi is equal to 2. 3 sine 2x. All right. Final question. This graph represents the effects of tides on mean sea level over a 24-hour period. Mean is just average. the graph has the equation A cos bt, where t is in hours and h is the height in meters above blah, blah, blah. Okay. First thing, look at the x-axis. It is time. All right, it is not degrees. So since it's not degrees, this means it's in rads. So you have to do everything in rads. Okay. First, find the a value. A is max minus negative 2. Max is 4, min is negative 4, which is 8/2, which is 4. Done, part of it. Now you have to find the period of this graph. Well, just go from this peak to that peak. 3, 6, 9, 12. Your period is 12 hours if you want, but I don't care about the units. So it's 12. But I need to find the b value. And remember, period is equal to 2 pi over b. So if I switch the 12 and the b, I get b is equal to 2 pi over 12. 2 over 12 is 1/6, so this reduces to pi over 6. So the equation of this graph is y is equal to a, which is 4, cosine, our b value, pi over 6, t. All right? Whenever you give an example, usually it'll be time. But if this x-axis value is not in degrees, it's telling you it is in rads. Okay. This is the point where I'd ask you to do questions 8 and 12. And I believe that is it. Yeah, that is this lesson. Hopefully that made sense. Good luck.